Chapter 1, Section 3, Measuring Segments. Make sure you put the section and title at the top of the page number on the outer edge, the date on the inner edge. So, the distance between points A and B is the absolute value of their coordinates, or A minus B in absolute value symbols. Now you would write your solution, the length between A and B, as AB equals. Notice that if you're setting it equal to a number, there's no line over AB. When you're talking about the measurement, you just write it as AB. When you're talking about the line segment, you would write it as AB with a line over it. So that's why you can also say the length of line AB is blank. So let's say we have a point on the number line at -6. This is our A. And we have a point on the number line at +4. This is our B. So this is line AB, line segment AB, and we want to find out the distance between those 2 points. Well, you would take the absolute value of the A coordinate, which is -6, and subtract it from the B coordinate, which is 4. Do subtraction, keep the sign of the first, change it to addition, change it to a -4. That gives you the absolute value of -10, which means the distance, the length of AB is +10 units. Now the segment addition postulate says that if there's 3 points, A, B, and C, and they're collinear, and B is between A and C, then AB plus BC, so the length of AB plus the length of BC will equal the length of AC. So say we have 3 points. A, B is between A and C, so that's B, and here we have C. -2, -4, -6, -8, 2, 4, 6, 8. So we can see that B lies on -3, A lies on -7, and C lies on 6. So if we follow the segment addition postulate, it should be true that the length of AB plus the length of BC equals the length of the whole thing, the length of AC. So let's see if that's true. First, let's find out what the length of AC is, so the whole length. So the absolute value of the A coordinate, -7, minus the C coordinate, 6. This gives us, again, keep the sign of the first, change it to addition, change it to a -6. This gives us -13, which means the distance of AC of the whole thing is 13 units. Now we want to see if the distance of AB plus the distance of BC equals those 13 units. So finding the distance of AB would just be the absolute value of -7 minus -3. Keep the sign of the first, change it to addition, change it to addition. This gives you the absolute value of -4, which means this distance is 4 units. BC, I'll do over here, -3 minus 6 in the absolute value symbols. Keep the sign of the first, change to addition, change to a negative. This gives you the absolute value of -9, which means the distance of BC is 9 units. once you take the absolute value. 9 plus 4 gives you 13, so this proves the segment addition postulate. So no matter what case you're talking about, if you're told that something is a line, then you can break it into pieces, and adding those pieces together gives you the whole. Now, using the segment addition postulate with algebra, you may see something like this. They'll give you a line, segment, AC, and tell you that some point B is between A and C. And they're all collinear, so they fall on the same line. This must mean that AB plus BC equals the whole line segment AC. So if it's stated that AB is 8x minus 14, and BC is 4x plus 1, and they tell you that the whole segment AC is 59 units long, take a second to pause the video and try to figure out a way that you could figure out the length of each segment, AB and BC. Using the segment addition postulate, you can tell that this must be true. AB plus BC must equal AC, so set it up just like that. AB, 8x minus 14, plus BC, 4x plus 1, must be equal to the whole thing, 59. So now we can combine our like terms. 8x and 4x gives you 12x. And negative 14 and positive 1 gives you negative 13, which must equal 59. By adding 13 to both sides, we get 12x equals 72. Divide by 12 on both sides, which means that x equals 6. But that's not our final answer, because the question I asked was, what is the length of each segment? Well, if x equals 6, by plugging 6 into this expression, we can figure out what the length of AB equals. So, since AB equals 8 times the number 6 minus 14, we can see that 48 minus 14 is going to give you 34 units. We can do the same thing for BC. BC equals 4 times 6 plus 1, which means 24 plus 1, so BC equals 25 units. And as you can see, BC plus AC gives you the total 59. 25 plus 34 gives you 59 units. So that's one way that we can use the segment addition postulate to help us solve an algebraic equation. Now, when something is said to be congruent, that means that they're the same length, they're the same size. So if you have two segments, AB and CD, you show that they're congruent by putting a single dash through both. So if they have the same number of dashes through them, that means that they're congruent to each other. Now when we say congruent, we write it as line segment AB is congruent, equal sign with a little curve above it, to line segment CD. When you're talking about equivalency, you say AB equals CD. So when you're talking about congruency, you have a line over the top. When you're talking about the measurement, the actual size, you just write A, B, and C, D with nothing written over the top. So the midpoint of a line segment is a point that divides the segment into two congruent segments. A point, line, ray, or even any other segment that intersects AB at its midpoint is said to bisect this segment, cut it in half, and this would be called the segment bisector. So in order to find the midpoint, you would add A plus B divided by 2, and that would give you the midpoint. So M is our midpoint. Any line, ray, or any other segment that goes through M, so let's say we have ray MR, is said to now be the segment bisector. This ray bisects the segment AB because it goes to its midpoint. If a line segment has a midpoint at 8 on the number line, and one endpoint is at 7, where is the other endpoint? So let's first take a look at our number line. 0, 2, 4, 6, 8, 10, -2, -4, -6, -8. Now you can see I'm skipping a dash in between. It still means that this line represents 3, 5, 7, and so on. Now, our example told us that the midpoint is at 8. So the midpoint is here. One endpoint is at 7. Where is the other endpoint? So if this is one endpoint A, this is the midpoint M, where is B going to lie? Well, the distance between A and M, the length of AM, would be absolute value of 7 minus 8, absolute value of -1, so that gives you 1 unit. If AM is 1 unit and M is the midpoint, that tells us that the other half of the segment has to be 1 unit as well. And 1 unit away from M would give you 9. So that means that B has to be at 9. Next question says, if a line segment has one